Hi everyone. Today we are going to deal with the cylindrical coordinates and spherical coordinate system. In three-dimensional coordinate system, we have three types of three-dimensional coordinate representation of a point in three types. That is, first we have already discussed. Okay, that is a rectangular coordinate, that is x, y, z coordinate. And next is cylindrical coordinate system. And the third one is spherical coordinate system. So, in the rectangular coordinate system, a point in a three-dimensional space can be represented in three ways. First one is rectangular coordinate system. Next is cylindrical coordinate system, and the last one is spherical coordinate system. Today, first we are going to discuss about what do you mean by a cylindrical coordinate system and how can you represent a point using the cylindrical coordinate system. Cylindrical coordinate system, and this is a cylindrical coordinate system in this. In the cylindrical coordinate system, what was a rectangular coordinate system? X, Y, Z coordinate. X, Y, in the X, Y means that is its points X, Y coordinates, and Z means its Z coordinate. In this cylindrical coordinate system, we are going to change this xy into the polar form. Actually, in this picture, they have shown that rho phi z. Actually, this rho phi means our polar coordinate. Polar coordinate means r theta. Okay, r theta z is the actually cylindrical coordinate system. R theta z. Okay, here they were represented it as rho phi z. Then how can you represent it? How can you take this? Okay, consider this is a point. Okay, neglect these portions, right? So only consider this point in a three-dimensional space and only imagine that there exists only this axis and this point. Then how will you calculate this cylindrical coordinate system? That is we are going to look through. Right. So in this rho phi z, rho phi in place of rho phi, you have to consider this as r theta. R theta is in the polar form. Right. So how can you find out this? Consider this point. Right. And in this point will, when it falls on the surface, this falls through this line, through the perpendicular line, and it will reach at this xy plane. Right? It will reach at the xy plane. At this xy plane, find its polar coordinate. How will you find out its polar coordinate? Its r theta is the polar coordinate, or rho theta. That is, rho means this is a point. Rho means its radius, that is radius. Phi means this is a point actually, right? Here in the xy plane, the point reached at this surface. And how can you find out these polar coordinates? This distance is actually rho, right? And how can you find out this angle? Plus angle from x-axis. Angle from x-axis that is calculated as phi. So this is the radius and this is the angle in the xy plane. This is the point actually. Okay. When it falls on this point, it will reach at this xy plane, right? And in the xy plane, the It's find a distance from the origin to this point. This is a row actually, right? And next is what we have to calculate angle. Angle from x-axis to this point, right? This is theta. Here it is calculated. It is written as phi. So this is, and what is said here? Find out the distance from this point to this point. This is the set. This is the height from the xy plane. If it is in the lower side, it also calculated it as minus sign. Minus sign, rho phi minus it. Okay. So this is a rectangular. This is a cylindrical coordinate system. Okay, look through this picture also. And this is a cylinder, right? Read these. The coordinate surface of the cylindrical coordinate rho phi z. Red cylinder shows the point with a rho equal to 2, radius equal to 2. When radius is equal to 2, what happens? Radius is equal to 2. This is the red cylinder. Okay, red cylinder shows the point with a rho equal to 2. The blue plane shows the points with a z equal to 1. The point with a z equal to 1 here. Z equal to 1 is a plane. Z equal to 1 is the plane. Okay. And yellow half plane shows with a phi equal to yellow half plane minus 60 degree. This is actually 60. This is minus 60. Minus 60 from the x-axis. And the z-axis is a vertical and a vertical line. This is the z-axis, and x-axis is highlighted in green. This is x-axis. This is z-axis. Okay. Do you get any imagination of this about this point? Look at this picture also. Cylindrical coordinate surface. The three orthogonal components. Rho is the green, phi is red, phi is the theta. Theta is rotating. Theta is rotating. Z is blue. That is the height. That is the height actually. Each is increasing at a constant rate. The point is the intersection between the three colored surface, and this form a cylinder actually. So this form a shape of a cylinder. So this type of representation is known as the cylindrical coordinate system. Okay. So how can you represent this? Cylindrical coordinate system. Cylindrical coordinate system. In this, actually this is the xy z axis. Consider this is a point x, y, z on this. Actually, the rectangular coordinate system means ഇതിന് എന്ത് ചെയ്യുക താഴേക്ക് ഇടുക ഇവിടെ എത്തും ഇത് സപ്പോസ് ഈ എക്സ് വൈ പ്ലെയിനിൽ ഇത് വൈ ആക്സിസ് എക്സ് ആക്സിസ് സെഡ് ആക്സിസ് ഓക്കെ ഈ പോയിന്റിലേക്ക് എത്തി ഇനി എന്ത് ചെയ്യും ഈ പോയിന്റിൽ നിന്ന് ഈ പോയിന്റിലേക്ക് ഇതിന് ഡിസ്റ്റൻസ് ഫൈൻഡ് ഔട്ട് ചെയ്യും ഈ ഡിസ്റ്റൻസ് സോറി ഇനി ഇതിൻ്റെ എക്സ് വൈ കോർഡിനേറ്റ് ഓക്കെ ആക്ച്വലി ഇതിൻ്റെ y ആക്സിസ് ആയിരിക്കും ആക്ച്വലി വരിക നെക്സ്റ്റ് പോയിന്റ് y പോയിന്റ് ഈ ഡിസ്റ്റൻസ് എടുക്കുക ഈ ഡിസ്റ്റൻസിലാണെങ്കിൽ ഇതിൻ്റെ എക്സ് വൈ വരും ഓക്കെ actually the y distance in the x distance xy varum ഇവിടുന്ന് ഇവിടത്തേക്കുള്ള height ആണ് actually height ആണ് z വരുന്നത്. This is xy z. And same point now, how can you represent it using the cylindrical coordinate system? This is the point. This is the point P. Right? Then when it falls down, and suppose this will reach at this point. How can you find out this polar coordinate? Find a distance from this point to this point. This is actually R. And find the angle from this is x-axis, y-axis, z-axis. Angle from this point to this line. Right? So this is theta. So this point representation is r theta actually. And the distance is this point from distance from this xy plane. In the xy plane, the point is here, and from this point to this point, the distance is z. So I can represent this as r theta z. R theta and z. Okay. When it varies, suppose this is a point here. Consider a point here. Okay, consider a point here. This point also lies in the same cylinder actually. Did you get any idea? This point also have the same r theta, but z is different, right? So this point lies in the same region, and also suppose this is a point, distance from this point, this is same. Okay. Suppose this is a point here, and in this point, right, consider this one. Consider this region. Here also, suppose the distance from this point to this point, and here is same. So r theta is same actually. R theta is same, but r is same here. Theta is different, and z is different here. Okay. Suppose here, consider the point here in the back side. Right. Here z is same, but r theta is different. Right. Not r theta is same. Right. So we have to look through. And the point also. Next, to consider this one, right? Here, what happened to this point? This is a blue. Blue is this is z is increasing. Z is increasing. Z is increasing means height is increasing, and when angle is at the first attempt. At the first attempt, what happened to this one? At the first attempt, the radius is very small, and radius is increasing. Theta is always from 0 to 360. Okay, z is increasing from minus infinity to plus infinity. Okay. And this radius moves from when at the first attempt it is increasing from 0 and increasing to a higher value, that is infinity, right? So what will be the values? R theta z, r varies from, radius varies from 0 to infinity, theta varies from 0 to 2 pi, and z varies from minus infinity to infinity. These are the points in this. Okay. Clear അല്ലെങ്കിൽ ഒന്നുകൂടി അടുത്ത ദിവസം എടുക്കാം കേട്ടോ. പറഞ്ഞാൽ മതി. വീഡിയോ കണ്ടതിന് ശേഷം പറയാം എന്താണെന്നുള്ളത്. സിലിണ്ടറിക്കൽ കോർഡിനേറ്റ് സിസ്റ്റം, ഇതിൻ്റെ ഇനി ടൈപ്പ് ഓഫ് കേസസ് ഉണ്ട്. ആ കേസസും കൂടി ഞാൻ പറഞ്ഞുതരാം.